Hello children, how are you? I hope you all are fine. Welcome to mathematics class for class 10. Children, today we are going to do chapter number 11, constructions. In the previous classes you have already done how to draw angle bisector of an angle, how to draw the perpendicular bisector of a line segment, how to draw a line parallel to a given line, how to construct triangles when its measures are given, as well as how to construct quadrilaterals when their measures are given. So children, using all this knowledge, let us see what more can be achieved or constructed with the help of your geometry box. Children, what is this? It is a line segment. Now can you divide this line segment into two parts? Very easy, isn't it? But what if somebody asks you to divide it in a ratio of 1:3 or 3:5. So let us learn how to divide a line segment in a given ratio. Now suppose I have a line segment AB is equal to 5.8 cm and I want to divide it in the ratio of m:n, where m and n are positive integers. Let us take m:n is equal to 3:2. Let us start with the construction. Draw a line segment AB is equal to 5.8 cm. At point A, draw a ray AX making an acute angle with AB. Now with a convenient radius and keeping the tip of the compass at point A, draw an arc cutting ray AX at point A1. With same radius and keeping the tip of the compass at A1, draw another arc cutting AX at A2. Similarly, we locate points A3, A4, A5 such that AA1 is equal to A1A2 is equal to A2A3 is equal to A3A4 is equal to A4A5. Join B with A5. Through point A3, draw a line parallel to A5B. For this, we take a convenient radius and draw an arc keeping the compass at point A5, cutting AA5 at point M and A5B at point N. With same radius, keep the tip of the compass at point A3 and draw an arc cutting AA5 at point P. Now keep the tip of the compass at point M and adjust the compass in such a way that tip of the pencil reaches point N. Now with same radius, keep the tip of the compass at point P and draw an arc which cuts the previous arc at a point. Let the point be Q. Join A3Q and extend it to meet AB at point C. Children, do you notice that A3C is parallel to A5B? And why is it so? Because we construct angle AA3C is equal to AA5B, which are corresponding angles for these line segments A3C and A5B. So children, point C is such that AC is to CB is equal to 3:2. Children, let us reason out why is it so. Now in triangle AA5B, A3C is parallel to A5B. So by basic proportionality theorem, AA3 upon A35 is equal to AC upon CB. That is, AA3 upon A35 is equal to 3 upon 2. That is, 3 upon 2 is equal to AC upon CB. Children, there is an alternate way of doing such a question. So let us do another question with the alternate method. Draw a line segment of length 5.8 cm and divide it in the ratio of 5:8. Measure the two parts. So let us first draw a line segment AB of length 5.8 cm. Now draw ray AX such that angle BAX is an acute angle. Here I have drawn an angle of 60 degree. Now draw the same acute angle at point B to get ray BY. With AS center and convenient radius, draw an arc cutting AX at a point, say A1. Now with A1 as center and same radius, draw an arc cutting AX at point A2. So we get AA1 is equal to A1, A2. Similarly, mark points A3, A4, A5. We are taking 5 points because first number in the ratio 5:8 is 5. Now in the same manner, we will get 8 points on BY like this. That is B1, B2, B3, B4, B5, B6, B7, B8. Join A5 with B8. Let it intersect AB at a point, say C. Then AC is to CB is equal to 5:8. Let us see why do we get AC upon CB is equal to 5:8. You can see there are two triangles, triangle AA5C and triangle BB8C. Are they similar triangles? Why? According to which criterion? We have a very simple criterion, that is AA criterion. So you can see that these two angles are equal. Yes, angle CAA5 is equal to angle CBA8 and angle ACA5 is equal to angle BCB8 because they are vertically opposite angles. So triangle ACA5 is similar to triangle BCB8. So we know that all corresponding sides in similar triangles are in equal proportion. So what do we get? AC upon BC is equal to CA5 upon CB8, which is equal to AA5 upon BB8. That is AC upon BC is equal to 5 upon 8. Let us measure AC and BC. What do you get, children? So this is how we can divide a line segment in a definite proportion. So where do we use this? We can use these methods to construct a triangle similar to a given triangle whose sides are in a given ratio with the corresponding sides of the given triangle. So children, let us learn how to construct a new triangle which is similar to a given triangle according to a scale factor. Now what is a scale factor? Scale factor is the ratio of the sides of the new triangle to be constructed to the corresponding sides of the given triangle. We will be doing two cases. Case 1, when the triangle to be constructed is smaller than the given triangle. That is, the scale factor is m is to n, where m is smaller than n. And case 2, when the triangle to be constructed is bigger than the given triangle. That is, the scale factor is m is to n, where m is greater than n. Let us first start with case 1. Draw a triangle ABC with sides BC is equal to 6 cm, AB is equal to 5 cm and angle ABC is equal to 60 degree. Then construct a triangle whose sides are 3 upon 4 of the corresponding sides of triangle ABC. That is, of scale factor 3 upon 4. Children, in previous classes we have learned how to construct this triangle when 3 of its parts were given. If we draw a rough sketch like this, we can see that AB is equal to 5 cm, BC is equal to 6 cm and angle ABC is equal to 60 degree. So we are given two sides and the included angle. Draw a line segment BC of length 6 cm. At point B, draw an angle of 60 degree. Now with a radius of 5 cm and center at B, draw an arc cutting 60 degree angle ray at point A. Join A and C. We get triangle ABC. Now we will draw an acute angle CBX, say 60° angle, on the side opposite to vertex A. We will open our compass to a small convenient radius and keeping the tip of the compass at point B, draw an arc cutting BX at point B1. Then keeping the tip of the compass at B1, draw an arc with same radius B2 cutting BX. So BB1 is equal to B1, B2. Similarly, we will draw arcs B3, B4. Why 4? Because in the scale factor of 3 upon 4, 4 is the larger number. So we take as many arcs, that is, we are taking 4 arcs. Join B4 with C. Now we will draw a line through B3 parallel to B4C. We are taking B3 or third point because in the scale factor of 3 upon 4, 3 is the smaller number. And here we are constructing a triangle which is smaller than the given triangle. For this we will take a convenient radius and draw an arc from B4 cutting BB4 at D and CB4 at point E. Then make a similar arc at point B3 cutting BB4 at F. And now we will keep the tip of the compass at D, adjust the other leg of the compass so that it reaches E. This gives us a measure of angle DB4C. And we are going to make same angle at point B3. So keep the tip of the compass at F, draw an arc cutting this arc at point G. Join B3G and let it intersect BC at a point, say C dash. So B3C dash is parallel to B4C. Similarly, we will draw a line C dash A dash at point C dash parallel to CA like this. So we get a new triangle A dash B C dash. Children, this triangle is similar to the given triangle ABC. Can you tell me why? Can you see, children? Two angles of triangle A dash B C dash are equal to two angles of triangle ABC. Because of which angles are they similar? Angle B, which is common to both, and if we look at angle A dash C dash B, and we have constructed in such a way that it is equal to angle ACB. And let us see how new triangle is 3 upon 4 of the original triangle. According to construction, BC dash upon C dash C is equal to 3 upon 1. That is, we have divided BC in the ratio of 3:1. Therefore, BC upon BC dash will be equal to BC dash plus CC dash upon BC dash, which is equal to BC dash upon BC dash plus CC dash upon BC dash. That is equal to 1 plus CC dash upon BC dash, which is equal to 1 plus 1 upon 3, that is 4 upon 3. So BC dash upon BC is equal to 3 upon 4. And since two triangles are similar, all sides are in equal proportion. That is A dash B upon AB is equal to A dash C dash upon AC is equal to BC dash upon BC is equal to 3 upon 4. So all sides of new triangle are 3 upon 4 of the sides of the original triangle. Let us do another question. Construct an isosceles triangle whose base is 8 cm and altitude 4 cm, and then another triangle whose sides are 1.5 times the corresponding sides of the isosceles triangle. Children, we know that in an isosceles triangle, two sides other than the base are equal, and perpendicular bisector and altitude of such a triangle from the vertex to the base, they coincide. So first of all, let us draw the base, say PQ of length 8 cm. Now let us draw perpendicular bisector of PQ. Children, do you remember how do we draw the perpendicular bisector of a line segment? Yes, for this keep the tip of your compass at point P and take the radius equal to slightly less than the length of PQ. That is, it should be more than half of PQ and slightly less than full PQ. Draw two arcs, one above PQ and another below PQ. Now keep the radius of the compass same and shift the tip to point Q. Draw two arcs, again cutting the first two arcs at 2 points respectively. The 2 points can be named as point M and N. If we join M and M, we get a line segment MN which is intersecting PQ at point O. With OS center and radius 4 cm, draw an arc cutting MN at a point, say R. Join PR and RQ. So children, we have got OR which is perpendicular bisector of PQ and it is of length 4 cm. This is the altitude of this triangle, and if we join PR and RQ, we get an isosceles triangle. Now we have to draw another triangle whose sides are 1.5 times or 3/2 times of the sides of this triangle. Here scale factor 3/2 is such that numerator is greater than denominator. So we will get a triangle which is bigger than the original triangle. For this we will draw an acute angle, say of 60 degree at point P, namely angle QPX. With PS center and a convenient radius, draw an arc cutting PX at point P1. Now with P1 as center, draw another arc cutting PX at P2. Similarly, we will get point P3. Why 3 points? Because 3 is the bigger number in the scale factor of 3/2. Join P2 with Q. At point P3, draw a line parallel to P2Q and such that it intersects PQ extended at a point Q dash. Now at point Q dash, draw a line Q dash R dash parallel to QR intersecting extended PR at R dash, like we did earlier. So we get a new triangle PR dash Q dash which is similar to original triangle PRQ. Because angle P is common to both triangles and angle PQR is equal to PQ dash R dash by construction. So we can say that the two triangles are similar and hence PQ upon PQ dash is equal to QR upon Q dash R dash is equal to PR upon PR dash, because corresponding sides of similar triangles are in proportion. So thus we say that 2/3 is equal to QR upon Q dash R dash, which is equal to PR upon PR dash. So Q dash R dash upon QR is equal to PR dash upon PR is equal to 3/2. Or we can say that sides of new triangle are 3/2 or 1.5 times the original triangle. Children, based on what we have done today, let us do a few multiple choice questions. To divide a line segment AB in the ratio of 4:7, ray AX is drawn first such that angle BAX is an acute angle. And then points A1, A2, A3 and so on are located at equal distances on the ray AX and the point B is joined to. You have 4 options: A12, A11, A10 and A9. So children, which is the correct option? The correct option is A11, because total number of parts is 4 plus 7 is equal to 11. Question number 2. Which theorem criterion we are using in giving the justification of the division of a line segment? You have 4 options: SSS criterion, area theorem, BPT, that is basic proportionality theorem, or Pythagoras theorem. So the correct option is, children, C part, that is BPT theorem. To construct a triangle similar to a given triangle ABC with its sides 4/3 of the corresponding sides of triangle ABC, first draw a ray BX such that the angle CBX is an acute angle and X lies on the opposite side of A with respect to BC. The minimum number of points to be located at equal distances on ray BX is, you have 4 options: 3, 4, 7, or none of these. The correct option is B part, that is 4. Next question. To construct a triangle similar to a given triangle with its sides 2/5 of the corresponding sides of triangle ABC, first draw a ray BX such that angle CBX is an acute angle and X lies on the opposite sides of A with respect to BC. Then locate points A1, A2, A3 and so on BX at equal distance. And next step is to join. You have 4 options: A part A7 to C, B part A2 to C, C part A5 to C, and D part A4 to C. Children, the correct option is C part A5 to C. So children, this was part 1 of grade 10 chapter 11 constructions. In this part we learned how to divide a line segment in a given ratio, how to draw a triangle similar to a given triangle according to the scale factor. In the next part we will be doing how to draw tangents to a circle. Till then, keep practicing. Stay healthy, stay safe. Goodbye.